Okay, so we're going to get started now on our Soccer Euro Cup prediction. It's a hands-on lab, and we're going to be building a forecasting model, prediction model with Snowflake ML. So hi everyone, I'm Simon. I'm the Director of Solution Innovation, specializing in AI ML. I'm excited to be here with you today to walk through our lab and hopefully see England predicted as Euro 2024 winners.
All right, well, welcome everyone. I'm Matteo. I'm a sales engineer based in the beautiful city of Amsterdam. Thank you all for being here today, and I'm thrilled to share a very cool hands-on lab on Snowflake. Let me hand it back to Simon to cover quickly the agenda.
Okay, so this lab covers a lot, so I hope you're all ready to learn. We'll start walking through an overview of Snowflake ML and the various features available within our platform. Then we'll discuss what we're building today with an end-to-end ML pipeline entirely in Snowflake. Then we'll be the hands-on lab where Matteo and I will be walking you through 5 notebooks that will cover all the steps needed. And then finally, we'll review the work we've done and summarize the key takeaways.
Cool. Well, maybe I actually forgot to mention, but it should be clear from my accent that I was born and raised in Italy. So that's why the main objective of today's session is not even about predicting maybe, but simply confirming that Italy is going to win the Euro Cup. I will be honest, I might have fine-tuned a little bit the dataset, but yeah, let's see how it will go. Joke aside, as Simon shared, we've got some exciting objectives lined up, and we are kicking off with a bit of technical know-how before we dive into the real coding action. So by the end of our session, we'll walk through a complete data science use case with Snowflake. We'll use Snowpark ML API, model registry, and guess what? Well, we will be using our brand new Snowflake notebook, which is available in all Snowflake supported cloud and regions. So hand it over to you, Simon, for the pre-match warm-up.
Thanks, Matteo. Okay, so Snowflake ML is the integrated set of capabilities for end-to-end machine learning on a single platform, next to your governed data. Snowflake ML can be used for streamlined and fully custom workflows. For streamlined ML, analysts can use ML functions to shorten development time or democratize ML across your organization with SQL from Studio, our no-code user interface. For custom ML, data scientists and ML engineers can leverage a suite of features for ML development and operations from Snowflake notebooks or any IDE of choice. Snowflake ML offers Python APIs accessible from the Snowpark ML library for the entire ML lifecycle from pre-processing to operations. In summary, Snowflake ML provides scalable feature engineering and model training with Snowpark ML modeling, distributed processing out of the box using CPUs and GPUs with code execution in the warehouse runtime or container runtime, and unified management of features and models with the feature store and model registry.
Yeah, all right. Well, thanks, Simon. And guys, we are getting here. So before we jump into the hands-on lab, let's have a kind of a drill down on those 3 main features that we'll be using: notebook, Snowpark ML modeling, and model registry. So regarding the Snowflake notebook, what is it? Well, I love how Snowflake kept it simple with the naming for our notebook. So it's exactly what it sounds like. It's a notebook, a beautiful, shining notebook. Within this notebook, of course, you have a kind of dynamic workspace where you can construct your pipelines interactively, whether it's through markdowns to annotate some stuff or SQL, Python code. You have the power to crunch your data right in there. Why should you use it? Well, we just say that. So you can simplify your processes right now. You can simplify your data workflows. And let me add a little bit. You can keep everything consolidated, not just about your data, but your code as well. You can keep your code and the data in the same place within the secured Snowflake boundaries. How to use it? Is it complex? Do I need to install something? No. Well, trust me, you will see it actually in 10 minutes probably. You'll get on top of it in no time. You can create your notebooks directly within Snowsite. You can even import an existing project that you created with another notebook. You can sync notebook with a remote Git repository for versioning and control, which is always good. And something I really appreciated is that in case I want to automate tasks, let's say, I can schedule the notebooks I'm creating to run as part of a data pipeline. So I can schedule my notebook to run at a decided frequency. Regarding the Snowpark ML modeling, well, we will use a bunch of features in our notebooks, not just these 3. But the Snowpark ML modeling is what we will be using in regards to model development and training. And what exactly is this Snowpark modeling? Well, it's a popular framework for feature engineering and ML training, like Simon was just mentioning to us, that can run directly within the warehouse or container at times in Snowflake. Why should we use it? Well, there are two main reasons. Maybe there are way more, but two main reasons I would like to focus on. The first one is the scalability when it comes to pre-processing. Because, for example, here in this slide, we have the one-hot encoder. If you are processing it as part of the Snowpark ML modeling, what you're doing is to push down all the computation on the virtual warehouses, which means that you can leverage the Snowflake virtual warehouse scalability in, out, across, out. You know better than me, right? So there is no out-of-memory issue, because whenever you are getting there, whenever you're loading very large data set, you are pre-processing very large data set, you can always scale up the warehouse, as we will be doing for the hyperparameter tuning. And yeah, you can keep working with no stress. In regards to model training, that's the second aspect, peculiar aspect that I would like to share, is that you have access to the most popular ML and deep learning frameworks, PyTorch, sklearn, XGBoost, and so on, all within Snowflake, which means that if you have to train a model, if you have to do inference, you don't have to move data out of Snowflake, train the model in some other services, store the model somewhere else, do the inference in some other ways, or maybe send it back to the data platform. Now you can do all this operation in one single place. So even from the security standpoint, this means that the data, whenever you are powering this kind of data science workloads, is not leaving your data platforms. How to use it? Well, today we will be using it mainly in our Snowflake notebooks, but in case you want to keep using your preferred notebooks outside of Snowflake, you can just import the library and you are ready to go. Last but not least is the model registry. Okay. And also this one is fairly easy probably to understand what is that. So once we have developed the model, once we have trained the model, we want to store it somewhere. Okay. And that's what Snowflake Model Registry stands for, is an integrated solution to manage and share AI/ML models and their metadata, like for example, accuracy and so on, natively in Snowflake. What's interesting is that under the hood, this Snowflake Model Registry is based on a new schema level object, which is the model. So like you have tables, views, stages, you will have also the model entity, let's call it in this way, within your schema. And this will provide you a versioned container of ML model artifacts with full role-based access control and APIs for Python and SQL to push it, pull it, to make any kind of operations on top of your models. How to use it? Again, same story. You can either use it on Snowsite, and we will see the UI later on. You can pull the models from your notebooks in Snowflake or any other tool of your choice. And that's it. That was a very fast, walkthrough of some of the features we will be covering. Now it's time to get our hands dirty. So Simon, handing it over to you for the first half, designing pipeline.
Great stuff. Okay, so we're getting close to the fun part. Let's just talk quickly about what we're going to be using. So Matteo and I have brought together some great data sets that we're going to be using as part of our lab. These include historical rankings. So we have over 64,000 historical rankings for every international team over the last 30 years. We have historical match results. So we've got every single international fixture, including competitions and friendlies from the last 80 years. This includes England's 1966 World Cup final against Germany at Wembley Stadium. Most importantly, though, we have all of the upcoming matches for Euro 2024 through the months of June and July. So with this, we're going to try and build out a prediction model that's going to simulate all 51 games and determine who we think is going to be the winner on July 14th in Berlin's Olympic Stadium. Using these data sets and the power of Snowpark ML, you'll be working through the full ML lifecycle and learn how we can take raw data, ingest it into Snowflake, transform it using Snowpark, and train a model to make predictions, all within the boundaries of your Snowflake account. So Matteo, let's get going.
Yeah, all right. Well, it's time. Second half, hands-on lab. So let me move to our UI, that's no site. Before we jump into the 5 notebooks, we will walk through a couple of pre-requirements for this hands-on lab, which are fairly simple. First thing first, to execute the setup.sql, which is coming in the GitHub repository, which is part of the GitHub repository. We will be creating here the database, couple of stages, and the warehouse that we will be using ad hoc for this hands-on lab. Of course, once we created the stage in the previous in the setup.sql, we can load the dataset that Simon was just mentioning. So with these steps, we can load the files, the fixture, ranking, and results into our stage. That's the only prerequirements we need to have in order to run our 5 notebooks. So here we are. These are the notebooks. Finally, here we go. I will run all the cells. Maybe I'm gonna do it like this. And I'll try to see if I can keep the pace of the execution. Otherwise, I will just walk through some kind of highlights while the notebook is executing. What we are doing in the first ingestion notebooks? Well, you saw that we just imported the files in our stage. What we want to do is to move them into staging tables. All right. And this is why we are, well, in the first step, we are getting an active session, and then we are creating a file format based on the files that we have in our stage. There is a file format which is covering the fixture and ranking CSV. The result CSV was slightly different, so we created another file format. And then here we are interactively loading them in a for loop, both fixture and ranking at the same time. And we are letting the infer schema function to populate for us, which are the columns of those 2 tables. Regarding the results, we are using a more old-fashioned style. We are just creating a table referencing the results.csv in the from statement of this query. As simple as that, we loaded our data. Now, something I was forgetting. We realized with Simon while we were reviewing those datasets that there were some countries that weren't reconciling across the different datasets. So we did some changes. We left just one for educational purposes. So we have been updating the country shortcode or country names in order to make sure that across all the different datasets, the names were identical. Once the data is loaded, we can see which are the tables we just loaded. And we can also verify, as Simon was mentioning, the only World Cup that England won in the history, while Italy is already at 4. And let's see if then in a couple of years how these statistics are going to change. I have to say that most likely neither England or Italy are going to win the next World Cup, but let's see. But yes, the data is there. We can see England, Germany, amazing match, 1966. I don't know if I remember correctly, it was actually in Wembley, the final. So I think it was a massive one. Good stuff. Data is there. Like is there also the fixture. So those are the 51 match. Of course, we know already which is going to be the pairing for the group stage. And we will see during the last notebook how we are going to pair actually for the round of 16 quarterfinals and so on, according to how we are predicting, the group stage, how we will end up in the group stage. So that's for the ingestion. Data is there. Now, Simon, what's next?
Okay, so let's move on to the data transformation stage. Okay, so once we've loaded the libraries and got our session loaded.
May I run them all or I run one by one?
Yeah, let's do that.
All right, let's do it.
So load the libraries, get our active session, and we just set quickly a username variable so we can create user-specific databases as we're going along. So first and foremost, we want to get a base data set of historical data, and we start with 1994, so we get around 30 years of history. So we get our historical matches and our rankings. And just to be clear, we are excluding friendly, so we're only focusing on competitive games. What we need to do now is we need to get the rank of each team at the date of each match. And so to do that, we're going to perform a join and then order the rank table by date to get the most recent one relative to the match date. And so we do this for both the home team and the away team. And then we join this together in a data frame called df match rank. If you scroll down a bit further. Okay, there we go. So then we have a list of fixtures and then the respective home team rank, and then the away team rank as well. Okay, so next we want to get the trailing performance for each team going into a match. And so for this, we're going to use the UDTF to aggregate the trailing games into historical statistics. To use this, we'll start with a fresh data set, and we'll use the UDTF to calculate the trailing performance for both the home team and then the away team. Like with the rank data frame, we'll join this together into a data frame called DF team perf. So if you keep scrolling down. Okay, there we go. So we now have a data frame that contains the trailing performance for both teams going into that fixture. I think in this case, we're using the trailing 15 games, but you can adjust this to see if you get any change to the model accuracy in the next step. The final step, we bring together these two data frames along with a column that determines the neutrality of the game, i.e. where it was played, and we also need to determine our target variable. So in regards to the target variable, so when we initially built this model, we modeled it based on multi-class prediction, so win, draw, or loss, and we were getting a low accuracy of around 55%. So we've rationalized the outcome to a home win or loss. What we then do is run the prediction for each match twice, once for the home team, once for the away team. And then finally, we combine the outcomes to determine the result. So a home team win and an away team loss is a home team win. A home team loss and an away team win is an away team win. And then if both teams win or lose, then the outcome is a draw. And so at the very end of our notebook, if you keep scrolling down, we will have a final data frame that contains our neutrality with a neutral flag, the trailing performance for each team. And then if you scroll across a little bit, we should see, there we go. We've got also our target variable calculated there as a 1 or a 0. You'll also note that we don't explicitly call out the home team rank or the away team rank. What we do is we calculate the difference between the two ranks, because that's far more important than actually the actual rank value. So now we have our training data set, and we're going to move on to the next notebook now, which is the modeling stage. Back to you, Matteo.
Thanks. Yeah. Let me run them all as well. I mean, let's keep this as a behavior to streamline the demo. Also, because here there is the hyperparameter tuning that might actually take a bit longer, but we will get there. So business as usual at the beginning, we are importing our libraries, we are importing the context, extracting the username to use it eventually if we want to create some ad hoc objects for our own users. And yeah, let's start with some real stuff. This function is the get next version function. We will be using it as part of the model registry once we train the model, and once we have it ready to store it in our model registry, we will use this function to check which is the last version in our model registry, so that we can keep a kind of sequence, so we can create the next version ID for this model. As a second step, we are checking the distribution, because whenever we are training the model, we want to make sure that the dataset is equally distributed across the two categories we are trying to predict, so loss or win, 0 and 1. And we see that it's quite fairly distributed. And then before the hyperparameter tuning, this is what I was mentioning during the slides. Now we can scale up and down as we need. For example, initially the Euro 2024 virtual warehouse is actually an extra small warehouse. We are scaling it up to a 2 extra large warehouse. So I don't know how much bigger, but way bigger than an extra small. And it took just 3 seconds. Because the hyperparameter tuning might take a while, and actually it's just over now, what we are doing with the hyperparameter tuning, we want to understand which are, for the XGB classifier, the best hyperparameters that we should use to get the best accuracy for our model. So the number of estimators, the learning rate, the max depth, those are the 3 hyperparameters we would like to understand which are the optimal ones. So we have our pipeline built using the Snowflake ML modeling library, where we do first a standard scalar. So we standardize the feature columns, and then we use the grid search in order to understand which are the best parameters in our case. Going quickly down, we can see that we can get a best accuracy of roughly 72% with those three optimal parameters that we are saving here in a variable that we will use in the next steps. Before we jump into the next step, we don't need, again, to keep a 2 extra large running for the training of this model, which is fairly small. Also, the dataset we are using is quite small at the end of the day. So we scale it back to an extra small warehouse, and we are ready to run our model training. So first thing first, we are splitting between training and test dataset. And then as we did for the hyperparameter tuning, same pipeline, is just that in this case, we are using the XGB classifier and using, of course, the optimal params that we extracted from the previous step. And then we just run the prediction on the training model, on the training dataset and on the test dataset. And we will see that, yes, we are printing here that the training accuracy is 73%, and the accuracy on the testing dataset is a decent 71.5%. Now, this is for educational purposes. Probably is not the best accuracy that you will ever get in your life for a model, but in general, it's good enough for educational purposes. And usually this step is used in order to understand if there is any case of overfitting or underfitting based on comparing the training accuracy and the evaluation accuracy. But anyway, 72%, that's what we have. Let's see what we will predict with this good 72%. So our model is there. Of course, we want to store it somewhere before to move into the next steps. That's where it comes to our help, the model registry. And it's actually just a couple of commands to save it, to store our model in the model registry. We can give it a name. Well, that's obvious, I believe. We can get a version. And we have that function in order to, kind of build our sequence of version number. And then we can push to our model object the new version of this model. So the log_model is a function that is allowing us to push this model to the model registry. And if we want to keep track of all the models from from the notebook, we have this simple function that is allowing us to show all the versions that we currently have. Or even if we want to see it from the UI, it's right here. That's number 7. Let me refresh this page, and we should have also the one that we just pushed in a few minutes ago while the notebook was running. So here we go. That's the version number 8 that we just created. And if we click on it, we can actually see also the accuracy and evaluation accuracy as metadata that we stored together with the model. And those are exactly the ones that we had right now while we were training this model. And I believe that's it. Yes. So that's it in terms of model training and model registry, of course. So the model is ready to go. Before we jump into the prediction, we have the notebook number 4. Simon, what can you tell us about this number 4 notebook?
Thanks, Matteo. Okay, so if you could get us started then by pressing the run all, and we'll just step through. So again, importing the libraries, getting our session. So during this step, we're going to create some reusable functions, some reusable stored procedures. This is going to make our prediction pipeline a lot more lightweight and much easier to understand as well. First, we need to simulate a penalty shootout in the scenarios where we have a draw. Modeling this was actually very difficult. So we actually created a simple method that uses the sigmoid function and factors in the ranking delta between two teams. In reality, penalty shootouts are something of a coin toss. And they're so unpredictable. So this actually works out pretty well. Then if you move on, we have 2 UDTFs. These are used to calculate the match outcome from both game predictions. So we have 2 records going in, 1 record coming out. We actually need 1 UDTF for the group stage and 1 UDTF for the knockout stage, since the stages are handled somewhat differently. Then let's move on to the stored procedures. We've taken all of our data transformation code from step 2 and wrap this up into a stored procedure. This saves us a lot of time having to rewrite this for every single round of the tournament. Then we have some stored procedures to process the results and calculate the next games based on the outcomes of the previous ones. Because of the different ways in which the teams progress, for example, group stages versus knockout rounds, we have to have a few of these. But at the end, we should see the objects we've just created by using the show function. We should see we have 5 procedures and 4 functions, including one function that we created in step 2. And now onto the fun stuff, which is predicting the Euro 2024 winner and Notebook 5.
Well, we are here ready to discover who's gonna win the Euro 2024. I already clicked on the run all, so the notebook will discover before than us who is gonna win the Euro 2024, but we will get there at our own pace, right? I can see that Simon had some fun adding a GIF of Michael Owen scoring a beautiful goal, but let's look a bit on what's happening on the notebook. So we have here this navigation panel. I mean, we have been looking at it the whole time, but it's worth spending a bit of time here now. As you can see, what we are going through the group stage, then we are going through the prediction of round of 16, quarterfinals, semifinals, up to the final stage. And you can see that pretty much we are always using the same amount of functions and features and number of cells in general. This is because ultimately we try to standardize the prediction across all the different steps. There will be some differentiators, but it's pretty much the same. So what is happening is that at the beginning of each step, of each stage, at the beginning of the group stage, let's say in this notebook, we are showing the fixture, okay? Then we are preparing the data for prediction using one of the stored procedures that Simon was showing you a few minutes ago. Once the data is prepared for prediction, so we have all the features for the home and the away team, we are predicting the results for all the matches on that stage. And then at the very end of each stage, of each step, we are showing the results. So for the group stage, we are showing the rankings of each group, while for the round of 16, we are showing who is gonna go to the next round and so on. But it's pretty much the same. We are always following this 4-step procedure for each stage of the competition. So if we look at we can touch upon the group stage, maybe we will jump to the quarterfinals. Let's see how it will go. But if we look at the group stage, we had, this is the fixture with the round that we want to predict the results. These are we are invoking this stored procedure to prepare the data for the prediction. And these are all the features for each match. And we see that each match is counted twice because we are predicting the result for each match twice. And then based on what Simon was mentioning, we are defining who is going to win, if it's a win, a loss, or a draw. And then once the data, all the data preparation is completed, we are running the prediction. So for each match, we are predicting the result twice. And if we see a 0-1, it means that this match, for example, Germany versus Scotland, Germany is going to be the winner. If we see a 0-0, it means that is a draw. If in case we see a 1-1, that's a draw again. Or let's look at Italy. Here we see that Albania, Italy is one of the first match of the group stage. Albania 0, Italy 1. It means that Italy is going to win this match. We don't need any penalty shootout for the group stage, so we can still accept the draws. Here we are showing us we can also run the prediction by using SQL. It's exactly the same step of above, but here we are using Python. Here we are using the predict_proba function, invoking our model to predict those results. And at the end of the group stage, we are predicting, or actually we are summing all the different matches outcome for the final rankings of each group. So we have the first 2 that automatically are getting qualified to the next round, and we are managing also the best third qualified to go to the round of 16. So here we go. So we have Germany, Italy. I see England is still there. So, okay, let's see the round of 16. Same stuff, same procedure, same stuff. First step, we are showing the games that we are gonna predict the results. These are the 8 matches of the round of 16. This is the data preparation. We are using the stored procedure that Simon was showing before. It's time to predict the results, same strategy. But here there is one thing more. Because it's a round of 16, we cannot accept draws. So in case there is a draw, we are gonna go throughout a penalty shootout with the function that we defined in the notebook number 4. Oh, look at this. Okay, that wasn't on purpose, but it looks like Italy is gonna lose at the penalty shootout on the round of 16 against Poland. So
pretty accurate then.
Pretty accurate, yes. I mean, definitely this is because of the penalty shootout function. Maybe we have to review it a little bit, but no, joking aside, yeah, England is still on the run. So everything is like this. The quarterfinals, same story. Let's quickly jump on the semifinals. Let's create a bit of suspense. We still have Spain, England against France and Belgium in the other semifinal. We are preparing the data. We are predicting the results. And I can already see that England is still right there. So it looks like we are going to have England and France as winner of the semifinals. And we have France versus England final. All right, let's see. I don't know if you want to announce it, Simon, who's going to be the winner. I can feel that there is a bit of suspense here.
England will never win. No.
Yeah. Here we go. France is the winner. Lovely GIF with actually Italy celebrating the last Euro Cup in 2020. I don't know how we managed to win that one, but we did it. Massive. And here we go. So we have the winner. France is going to win according to this model prediction, the Euro Cup 2024, with an accuracy of 72%. So let's say we still have hope for both Italy and England at the end of the day. Final summary, well, that's what we did right now. Simon, do you want to cover this, what does Cortex say, which is pretty nice as well?
Yeah, this is just a little bit of extra fun. I mean, this isn't necessarily the right use case for large language models, but I wanted to just see what Cortex would say about the Euro 2024. And so one way we could do this is we build a prompt, and then we're going to call Cortex with every single model that we have available in Cortex right now, or at least the main ones. And then if we move down, we can see what each model is predicting. And then a nice cool feature is, Snowflake notebooks are actually very interactive, and we can leverage a lot of Streamlit controls for this. And so we can jump between each of these models, and you can, adjust the prompt as you need. Press the predict button, and it will then come back with, which team that the respective LLM thinks. Obviously, England is a favorite of Snowflake Arctic. I'd love to see what perhaps Llama 3 thinks. And England again. Well, what a surprise! I can't deny that maybe there may be some prompt engineering happening behind the scenes. But all that aside, I thought this was a really nice way to cap off the hands-on lab, just demoing how Streamlit can also be used as part of the notebook environment to make it really interactive as well. I think that concludes the hands-on lab.
It's time for the highlights. So France is going to win the Euro Cup 2024 post-match highlights. So Simon, what did we do?
Yeah, that's it, everyone. We're able to demonstrate that we executed a full end-to-end data science tasks seamlessly within Snowflake. We didn't have to push it to another tool. We didn't have to reach out to an external endpoint. Everything we did today was entirely within the boundaries of a single Snowflake account. We managed to utilize Snowpark ML API and model registry, all of these new features that are now available to everyone in Snowflake to build this pipeline. And hopefully you've seen a great demo of all of this happening inside your Snowflake account, and proving once again that England are incapable of lifting a trophy in any kind of soccer-related activity. So with that, thank you, everyone.